Okay, so today we're going to take what we did yesterday, which is dealing with different types of variations, and we're going to apply it to real-world situations. A lot of the steps that we're going to take are the same steps that we took the day before, just applied to a different type of problem. So, first, I always read the problem. The cost C of a piece of PVC water pipe varies jointly with its diameter D and length L. A 20-foot piece pipe with a diameter of 1 inch costs $6.80. Write an equation that relate it C, D, and L. So when I read that, I get very overwhelmed because there's a lot happening. But I recognize that that first sentence really gives me the basic information I need to start setting up the problem, just like we did yesterday. So step one would be to write a general formula. So in this case, C varies jointly, means we're going to be multiplying by multiple things, in this case the D and the L. So we have C equals K times D times L. Then the rest of the information can start getting put in. So a 20-foot long pipe with a diameter of 1 inch costs $6.80. So this is giving me the information to plug in, where the 20 is the L, the 1 is the diameter, and the cost is C. So step 2 will be to substitute the given values. So in this case, that would be $6.80 equals K times 1 times 20. Now that I've got that substituted in, the goal is to find our constant K. So step 3 is to solve for constant K. So I'd multiply 1 times 20, so I have 680 equals K times 20. Now to get K by itself, we would divide both sides by 20. So K would equal 0.34. Now that I know what the constant is, I can go ahead and write the equation with the K replaced. So in this case, it would be C equals, instead of K, 0.34 times D times L. Now at this point, I always go back and I reread the problem, because if there's more things I need to do, they might have given me information and said, hey, what if this were to happen? What would the cost be? So we have to read through, and it just says, write an equation that related C, D, and L. Well, here's an equation with the number relating C, D, and L, so that's my final step. But in others, we want to make sure that there's not something else to do. So step 5, make sure to answer the question. Okay? All right, so let's go ahead and look at number 2. The resistance R of a wire varies directly with its length L and inversely with the square of its diameter. So be careful. A lot of times people want to skip this squaring the diameter. Make sure you read the whole thing and not just look for the letters that are in the word problem. So R varies directly with L, means R equals K times L, and inversely with the square of the diameter. So remember, inverse means dividing, so we're dividing by the diameter squared. Then as I read on, it tells me that the length of the wire is 20 feet, so L equals 20. The diameter is 0.1. And the resistance in ohms is 2, so that tells me my R equals 2. So I can go ahead and substitute this in. 2 equals K times L, which was 20, divided by the diameter, which was 0.1 squared. And just like with square roots, anytime you can get rid of a square or a square root, you should. So we're going to go ahead and square 0.1. So we'll have 2 equals K times 20, divided by 0.1 squared. which is 0.01. And now the goal is to get k alone. So I would get rid of the 0.01 by multiplying by it on both sides. And 2 times 0.01 would simply be 0.02 equals k times 20. And now to get rid of the 20, we divide by 20 on both sides. And 0.02 divided by 20 would be 0.001 equals our k. So now I can go ahead and write our equation. R equals, instead of k, I put 0.001 times L divided by the diameter squared. And when I read the end of the sentence, or the end of the question, it says write an equation that relates R, L, and D. So that's our equation. We're done with that problem. You might want to pause the video at this moment and try a few of these on your own, and then check back in to confirm that you've got them correct. All right, so number 3. In a downtown office building, the monthly rent R varies directly, so again, directly means multiplying, with the size of the office S. So we can go ahead and get our equation from that. So R equals K times S. As I read on, they tell me that there's a 420 square foot office building. Well, that would be the size of the office, so that tells me S is 420. Rents for $12.60 a month, so that tells me my rent equals $12.60, so I can go ahead and substitute that information in. So $12.60 equals K times 420. So now we need to get K alone, so we divide by 420. And 1260 divided by 420 is 3, so my K is 3. Now I can go ahead and write my general equation. R equals K, which is 3, times S. Now in every other problem, this ended up being the end, but we should always double check. So write an equation that relates R and S. Well, that's what we just did here, but it goes further. It says, what is the monthly rent for a 900 square foot office? So we're going to take this a step further. They're saying, how much am I going to have to pay if the square footage, which is S, equals 900? So now I'm going to plug that into the equation we created. So R equals 3 times, instead of S, we'll put in 900. And 3 times 900 is going to be 2,700. So R equals 2,700, and now we answer their question. So I would say the monthly rent for a 900 square foot office, and you need to put that 900 in there because if it were a different size, it would be a different cost. Costs $2,700. All right, so now you can go ahead and flip to the back side. We want you to try these on your own, and then you can either check with us tomorrow, or there may be a video up later that you can use to check your answers with.